ऑलराइट। तो देखो, अभी तक हमने क्या पढ़ा था कि सर्किट होते हैं, उसके अंदर रजिस्टर होता है, बैटरीज होती हैं, और देर आर टू अरेंजमेंट्स विच वर नेमली सीरीज एंड पैरेलल, राइट।
हम्म
जस्ट टू गिव यू अ कॉन्टेक्स्ट कि हम कर क्या रहे हैं, अब तो आपको पता होना चाहिए। सो द सीरीज एंड पैरेलल सर्किट वर एनालाइज्ड बाय अस, और हम एक सीरीज या पैरेलल सर्किट में ढूंढते थे कि यहाँ पोटेंशियल कितनी है, वोल्टेज कितनी है, राइट। तो वो जो सर्किट एनालिसिस था, सिंपल सर्किट्स पे था। ये दो
हम्म
सीरीज में एक बैटरी है, और एक दो ये सीरीज है, या यहाँ पे एक पैरेलल में ज़्यादा से ज़्यादा लगा लिया।
हम्म
तो what we were using so far is simple circuits. These are simple circuits where the concept of equivalent resistance, which is R1, R2 or R3 for example, in this circuit, it was easy to find out कि point A और B के बीच में क्या resistance है।
हम्म
So these were simple circuits. Now if we get into a situation where the circuit becomes a complex circuit, right? So let's say you have a circuit जिसमें it is not possible for you to decide what is happening. Okay, so let me
हम्म
just draw an example for you. And I draw a battery here, then I draw one more circuit here. Some parts of the circuit may be very easy to understand. Okay, and let me just draw one more resistance, and then let me draw a resistance here. यहाँ पे भी रेजिस्टेंस है, मान लो एक बैटरी है यहाँ पे, और ये मेरा सर्किट है, राइट। नाउ
हम्म
कंपेयर दीज टू सर्किट्स। दिस इज अ वेरी सिंपल सर्किट, पैरेलल
अच्छा
पैरेलल, उन दोनों का आंसर इन सीरीज विद दिस।
हम्म
एक सिंगल ईएमएफ का सोर्स, ओम्स लॉ लगा के आंसर आ जाता है। V
हम्म
इज टोटल is equal to I total multiplied by R equivalent.
हम्म
Quite simple.
यस
But
सर
in circuits which are not simple but complex, we need more rules and regulations than the knowledge of series, parallel and Ohm's law.
ओके
ये तो चाहिए ही चाहिए।
हम्म
इसके अलावा we need some more rules. Why? Because if you look into this circuit, it has multiple sources of EMF.
हम्म
राइट, अब ये दोनों तो सीरीज में है, बट इनका
यस
जो आंसर है वो इसके साथ क्या है पता नहीं।
हम्म
देर इज नो हार्ड एंड फास्ट दे कनेक्टेड टू द सेम, राइट। कोई ऐसा कोई पैटर्न नहीं है। ये
हम्म
दोनों सीरीज में है, बट इसके साथ यू डोंट नो।
करेक्ट
सो देयर वाज अ साइंटिस्ट, हिज नेम वाज, सम पीपल कॉल हिम किरकॉफ,
हाँ
Kirchhoffs, or whatever you want to call him.
हम्म
He gave two laws, but before we do the two laws, let's understand in a complex circuit there are certain points that need to be understood. Okay, if you see a complex electric network, and we are referring to DC right now because we just have the batteries. Okay, DC, we're not using alternating current, which is this. So in a
हम्म
complex electric circuit, which cannot be solved only by the use of tools like Ohm's law, series and parallel, it needs more tools. First, we will study that when we look at a circuit, what are the important points of the circuit that we always need to mark. So what
हाँ
you see in front of you, first of all, is called as a complex electric circuit. Multiple sources of EMF,
हम्म
multiple resistors connected in a way that you cannot break the code of series and parallel easily. It's very difficult,
हम्म
right? And supposingly I tell you there is a current here. Here you have a current. That current is because of this, this, and this. All three acting in a certain manner and creating that result at a location I'm telling you. So finding the current here is not like finding the current here. Here it is way too simple. Battery single goes, but this battery also creates a current which gets distributed in the circuit. This battery also creates a current in the circuit, and so does this. Each one of them, therefore, is producing a current, and those currents are getting in the respective electrical elements in a certain manner, which this gentleman was able to tell. He was able to tell you what are the rules for a complex circuit analysis, right? So what is our agenda? We are going to do a complex circuit analysis, but let's first see, whenever you have an complex circuit in front of you, what are the important points that need to be understood. Now, if you see these 2 points, okay, in a complex circuit, I will use a color coding here. So let's say I use green color. This point, okay, this point and this point has a resistor between it. The point number A and B have a resistor between them, right? The point number, this point has multiple electrical elements coming to it from the right, from the left, from the bottom. This point also has multiple electrical elements, one from here, one from here, which is this. So they are getting collected at all of them, and one is coming from the battery, and so therefore these points are of significance when we will do the analysis of the circuit. And these points where you have two or more conductors joining in, wherever you have two or more conductors joining in, are called as junctions. And generally they will look like this. When I say conductor, actually I mean resistor. Okay.
Hmm.
I'm drawing a complex circuit again, which is not easy to understand in one line if I say. It can be as complex as this. The first step is always to find out the places where you have the branch. For example, this is a branch.
Hmm.
Okay, so branch number 1, the branch number 2, and the branch number 3 is all getting collected here or connected here. So this will become a junction. The two or more conductors or two or more branches connecting at a point will become a junction. Okay, and any 2 points which are between the junctions will be known as a branch. So this is also a junction. This is J1, this is J2, this is J3, this is J4, this is J5, this is J6. If you look at J, and this is, so this branch is between J6 and J3.
Hmm.
This branch is between J3 and J1. Right?
Okay.
So we are now learning how to label the circuit. What are the components of a complicated electrical circuit? Branches are, these junctions are. Okay? Let's now look into the third component. Now, if you notice this part, the circuit number A, which we decided, let me show you something. You can see clear cut, these are closed loops.
Hmm.
A square in itself. This is a closed loop. This also is a closed loop, right?
Yes, sir.
It appears like an independent conducting path in the circuit. It appears to be an independent path. It is not an independent path because it is getting impacted by multiple EMF sources in one go. So for example, if you notice this particular circuit and I draw a loop in this circuit, this is another loop. It's a closed circuit. Okay, and we will call it a loop. This is another loop. another loop, right? I can also draw a loop like this, which covers
Hmm.
the whole circuit like this, right? So first thing you have to understand is when you look at the circuit is you will say where are the junctions where two or more conductors are joining, what are the branches. So you will find the branches also, and then you will, in the third step, identify the loops. There are ways to do each one of them, but you should know a new terminology coming in, which is the terminology of the loops, also called as a mesh, like a mosquito mesh. A
Hmm.
mesh is getting created within a complicated, complex electric circuit. And then, of course, you know what are, you have to identify the junctions. And then the third thing you have to identify are the branches. Here, there was no need. It was so simple, we never worried about junction and all that. And if you notice this point, for example, it has three conductors coming to it.
Hmm.
So even this is a junction, but it is so simple that I am not going to apply Kirchhoff's voltage law or Kirchhoff's current law to solve this simple circuit. But here I will.
Okay.
Right? Junctions were already there, but were of no importance. You will start noticing that soon these junctions will become very important points for the analysis of circuit. When I say analysis of the circuit finally yields you what? It tells you what is the potential here, what is the
Hmm.
potential here, what is the current here, what is the current here, what is the potential across this branch, and what is the current. It starts helping you find out the respective potential differences and the current in a particular branch. Once you start analyzing, you will come to know what is the current in this branch, what is the
Hmm.
current here, what is the total potential here. Very little
Understood.
effort will be required to use parallel and series and Ohm's law. They will always be required, but on top of that, you now need two more laws which are coming from Kirchhoff's. And before we learn those laws, first we will concentrate on learning the concept of what is a junction, what is a branch, and what's a loop.
Okay.
We are not getting into details of what they are. We're just worried about some positions on the circuit which are of importance to us. Now
Hmm.
let's talk about the first law of Kirchhoff. Okay, so the first law, what does it say? With limited knowledge you have, so first law, Kirchhoff's first law, or you can call it the law of junction. Okay,
Okay.
the Kirchhoff's law of junction. Okay, which means you must know the junction first in the circuit,
Hmm.
because this law gets applied only at the junction.
Understood.
What it says is identify a junction where there are more than three conductors, two or more conductors joining in. Identify them. Whatever currents are entering that junction,
Hmm.
the sum of them should be equal to the current which is leaving the junction. So if I have I1 plus I2 entering the J5, then the I3 is leaving the junction. So if I draw it another circuit for you, which is much more easier to understand, a very comparatively not so complicated, but still complicated. Okay, let me draw this. So you have this situation, and then you have one more situation, which is this. If you notice this, there are two loops you can identify in this circuit. Okay, I'll
Hmm.
come to what are loops. Loops are used in the second law. In the first law, we're worried about the junctions only. J is a junction here. Three or more conductors. One, two, and three. All are getting met here. As we assumed that current in this particular left side of the junction is moving out. It is I1, and then on the right hand side it is towards the right, I2, and then there is a current which is like this, I3. Right, this, how this current direction was decided, we will learn the rules very shortly, but right now our focus is, if this is the situation, Then the Kirchhoff's law, which is the current law or the law of junction, it is also known as KCL, Kirchhoff's current law, will
Hmm.
tell what on the left hand side write the incoming currents. So incoming current is I3. On the right hand side, write the outgoing current. So this is
Understood.
your incoming and this is outgoing. Assume a situation you have a junction where I draw a diagram like this. This is I1, this is I2 and I3. Then I1 is equal to I3 plus I2 at the junction J1. Let me draw one more case, and this will help you understand how they ask you questions in board and JEE mains. This was some conductor or a branch, and then there was another one, then there was another, then there was another, then there was another, and this was in a certain manner. Now the current coming here was 5 amperes. The current which enters is here is 3 amperes. The question is how much current is going out from here? The entry current is 5 amperes at the junction J1. The exit current is 3 amperes. Where is the balance here? Now look at both the exit currents. 3 plus 2 is equal to 5.
Hmm.
Now at this junction, 2 amperes enters. You have 1 ampere here, which is again coming in from somewhere.
Yes,
Look
sir.
at the junction 2. What current is entering J2 now? J2. What current is entering?
7.
How?
5 ampere and 2 ampere.
5 ampere already got split in two parts, 2
Achha,
and 3.
So J2 with 2.
Correct. And one is also coming from this side, 1 ampere.
Hmm.
So 2 ampere and 1 ampere both are coming inside. What current will leave J2 now?
3.
Correct. Now 3 amperes came in. 0.4 amperes are leaving the circuit here at junction.
Hmm.
What is this X equal to?
2.6.
Correct. Now 2.6 is entering. No current is visible here. How much current is exiting the junction?
2.6.
Correct. This is the junction law.
Okay.
Okay. And mathematically, you can also write it as sigma I is equal to 0, which means that there is no net current creation in this process. So if you look into a junction where the current is entering and then some current is exiting, for example, it is getting split. At this point, the net current which is going to stay is 0. There is no creation of, so why? Because the charges keep on flowing. If the charges are coming at some 5 coulomb per second, which is equal to 5 amperes, then 2 coulombs per second are going there and 3 coulombs here. So this is your 3 amperes, this is 2 amperes, and this is 5 amperes. My question to you is, how much current stayed back at the junction? 0.
0.
Nothing stayed back. So at the junction, the sum of currents is 0 because the sum of charges is 0. This figure is at the junction, right? Another way to write this is that sigma of I input is equal to sigma of I output. One and the same thing. Or you can write this, which is the sum of these two, input and output, which is getting subtracted, should be 0. The difference of input minus output should be equal to 0, right?
Yes, sir.
Or, so this is sigma I is equal to 0. One and the same. This is both the currents getting added, input and output, and the result is 0. The basis of law of Kirchhoff's for current is law of conservation of charge. No charge gets created at the junction or destroyed at the junction. So whatever charge is entering the junction leaves the junction at some rate. The way I just explained you. 5 coulombs entered and then you have 2 and 3 respectively.
Understood.
That's your Kirchhoff's law of junction. How will we use it later on? We will see. But first of all, pay your attention to the fact that you have to identify junctions, and then at the junctions you will apply what is called as a Kirchhoff's law of junction or the Kirchhoff's current law, whatever you want to call it.
Hmm.
Second, this scientist also found out that in a complex circuit, let me redraw the complex circuit. Okay, a complex circuit, and let's use the above one only. So this is your source of EMF 1, this is 2, this is 3, this is R1, this is R2, this is R3, this is R4. If you know, you can apply junction law here and here. But we've already understood that we're not worried about the junction anymore.
Yes,
What
sir.
we are going to be worried about now are the loops.
Hmm.
So I am going to use one loop, which is this on the left hand side. I can clearly see it's a closed loop made up of multiple branches. It starts from here, ends here.
Yes, sir.
Branch number 1, branch number 2, branch number 3, branch number 4. All of them get together and join at the same point.
Hmm.
And same is true for the next loop or the mesh.
Okay.
Now, what is the statement of Kirchhoff's voltage law is the question. What did Kirchhoff say about the mesh? Kirchhoff said the sum of all EMFs in the mesh you take will be equal to sum of the potential difference in the mesh.
Hmm.
Whatever EMFs appear in the mesh, take the sum of them and put it equal to the potential drop in the mesh. So for example, in the second loop, I can see one, if I take the arrow in this direction, I'm moving from positive to negative. There is a drop in potential. So I'm going to write minus E3. I go up, there is a gain of potential plus E2. So in
Hmm.
the mesh number 2, I have taken care of sigma EMF. The sum of EMF sources are on the left. I am considering mesh number 2. This should be equal to the potential drops in the resistors. So assume the current here was I3. What is the potential drop on this side? It is I3 R3. What is the potential drop here? Plus I3 R4. We've just learned the fact that the EMF sources are getting added as and when they come, depending on the sign. If it's a drop while you move through the loop, plus to minus, loss, negative sign. And if you move along the loop here, minus to plus, you have a gain. And then
Hmm.
the sum of EMFs should be equal to the sum of potential drops in the circuit.
Okay.
Okay. Broadly, Kirchhoff's voltage law is based on law of conservation of energy. So
Hmm.
whatever potential is existing in the circuit, whatever two pumps are working together in the circuit, that pump, whatever EMF it can provide, is getting consumed in that mesh.
Hmm.
Which is what made this rule very remarkable. Otherwise, we cannot apply any law in this loop. You cannot apply Ohm's law directly. You cannot. But this law is a very powerful law that you can treat a loop as an independent loop. The only problem is if I were to say this is R5, right? And this current which you took here is I3, another I3, and the current here was I I2, then the entering current is going to be I2 plus I3 because at the junction exit current is I2 plus I3. Therefore, the entry current is I2 plus I3. So I will readjust and write this as plus there is another drop which is I2 plus I3 multiplied by R5. I have taken potential drop here. I have taken potential drop here. Then I'm taking a potential drop here also because it's part of the mesh. Now you can see there are two currents here, two different currents. And then you can write another equation for this one. Make one more equation. Then solve both the equations. You will be able to find the I2 and I3 in the circuit. Assume the values of E3 and E2 are given to you.
Yes, sir.
So which means this technique is a very powerful technique. It helps you to recognize individual meshes in the circuit and then apply this rule that the sum of EMF in that mesh will be equal to the sum of potential drops in that mesh. It's a very powerful statement. It did not come from Ohm's law. Does not come from series. It does not come from anywhere except the fact that it comes only from the Kirchhoff's voltage law. And now if you combine these two laws with the Ohm's law and with the knowledge of series and parallel, you will see it's very easy to solve a complex circuit. And now I will get into details of sign convention, which is to be used in the analysis of a complex circuit, right? There is a trick on how to decide the sign. For example, I think this was straightforward. Minus E3 is a drop from positive to negative as you move along the loop. But how do you decide whether the loop which you will traverse or move will be clockwise or anti-clockwise, right? So if I take this circuit, I could have also decided to take the loop like this. And in this side also, I could have done it like this. How to decide this direction of the loop, whether to take it clockwise, move clockwise or anti-clockwise, right? Let's do a simple numerical and see for ourselves how to use the sign convention, because potential drops are generally drops, loss in potential. So this is the drop of the potential in the mesh, and on the left hand side is the pump of the mesh, which has multiple battery sources, but of course the battery sources are not getting added in this case, so the pump power is getting reduced and is giving a certain potential drop. So on the left hand side you have the sources of the potential, and on the right hand side there are consumers of that potential. And on the right hand side, at one place you had to use Kirchhoff's junction law also to find what current is entering at this place.
Okay.
Because you knew what is the current going out. So let's do a numerical as a sample exercise to make our life simple and see for ourselves how to solve a numerical, right? Comparatively simple. Our main agenda is going to be to learn how to apply the sign convention. How to use a sign convention on the potential drops, how to decide the direction of the loop, clockwise or anti-clockwise, right?
Yes, sir.
All right, let's do that. So we're going to use both the laws. The first law was based on law of conservation of charge. The second law is based on law of conservation of energy. Finally, the charge is moving, and if the charge is moving, then you're providing it some voltage difference. And therefore, the charges have potential energy, and they move from higher potential energy to lower potential energy. And they move continuously because the pump, which is a battery, keeps on moving continuously. Okay, let's talk about a simple sample numerical. So you have a question from NCERT now. This is your circuit, and we will do the same question from multiple directions of the loop and see whether the result we get is same or different. So this is more like a rectangle, and this is your circuit, and then you have a 60 ohms. This is 4 volt. This is 20 ohm. This is 1.5 volt. And this is 200 ohms. Okay. If you see the circuit, you cannot apply any series or parallel logic. Cannot.
Hmm.
Will not work. So it is a complex circuit. You cannot apply series and parallel nowhere. It is not possible.
Yes, sir.
So the first step is to identify the junctions. So let me just identify the junctions as places where three conductors are meeting, A and B. Tell me if A and B are junctions for you.
Hmm. Got it.
Agreed?
Hmm.
All right. Now, next step, you want to put some currents in each of the branch. So I'm putting the current in branch which is starting from B, moving towards this side, and same branch from here to here, right? So the battery sends out current from positive to negative. So current is coming out of the battery. Let's say this current is I1. Let me look at the second branch battery, and then current is also leaving the battery from positive terminal. Let the current be I2. So two currents are entering the junction A. What current will leave the junction A then? Any doubts in your mind? Feel free to ask.
No.
This makes sense, right? You have two currents entering a junction, and therefore the exit current should be the sum of the two currents.
The two currents.
So
Yes.
these two directions of I1 and I2, I decided based on my knowledge that current leaves the positive terminal of the battery, which means the current all across is this. And current here is all across this. Right? Because it's the same
Correct.
branch. If the current here is downward, in the upper part of the branch also, the current has to be I1 current then.
Hmm.
Single branch, single current. So current here is also I2 because it is I2 here.
Hmm.
Okay. So first rule we have used, which is the Kirchhoff's current law. We have applied the knowledge. And tell me, what is the current entering B? I1 plus I2?
Uh-huh.
What is the current leaving B? I1 and I2. So automatically that got fixed at B. The current entering B is equal to the current leaving B.
Hmm.
All right. Let's talk about. So we have applied this KCL. Let's come to KVL now. In KVL, I have to be worried about loop first, right? I have to apply KVL in a loop or a mesh.
Hmm.
Let me identify the mesh in the circuit, okay, or meshes. So let me use. So I know the current in the left-hand triangle, which is a closed loop starting from A and ends at A. If you go like this, let me show you. I will take the loop like this. Starts at A, ends at A. The triangle number ABD is a loop. It's a closed loop.
Hmm.
ABDA.
Okay.
Let's look into the second one on the right hand side. I will again see what is the preferably I would like to move in a direction where the currents are.
Hmm.
In this, I moved like this on the left hand side, right? My loop I am traversing in a anti-clockwise direction because I know the current is also anti-clockwise in the loop.
Yes, sir.
So when I will apply the Kirchhoff's voltage law, I also want to start moving anti-clockwise. Let's look into the second loop. And I see the current direction is going downward, then left, and then on a diagonal. Let me go through the loop like this, because why do I need to go through the loop? Because I need to write the potential differences, I1, R1. I will go one after another, and I have to write the I into R, and also need to decide what are the sources of the battery. Now comes the sign convention. Let's see. Now we have to apply Kirchhoff's voltage law, which states that sum of EMFs in a loop should be equal to the sum of potential drops in the loop. Let's look into the loop number 1. Tell me in the loop number 1, if you go in the way you are, for example here, which is the battery you will come across first, in which branch? DA.
Hmm.
And you're moving in which direction? Like this. So one is the direction of current, which you decided based on the battery signs plus. And you said current will always come out from positive side. And then you have another loop which you are going to traverse, because you have to traverse the loop to write this equation. So one current was this, that you decided based on the fact that current is coming out of the battery. The second you're worried about is the current, which is a loop's direction, which you yourself decided. I will move through this loop number 1 in an anti-clockwise direction, because it is convenient for me to move along the direction of the currents.
Okay.
You can also decide on the loop number 1 not to move in an anti-clockwise manner, but say I will not move like this. I would like to move like this. So I will start from A, I will go to D, I will go to B, and I will come back to A like this. You can. How you want to apply this left and right hand side is entirely up to you, but preferably apply it along the current. If the current direction is already known to you because of the battery signs, try and apply the loop direction, clockwise or anti-clockwise, along the current direction.
Okay, understood.
Both are anti-clockwise in the situation we have taken. Now let's start moving across the, so this is, now we are moving along the circuit. Assume you are traveling like this, okay? You're traveling. The first thing you come across is the battery. Will you see a gain of potential across the battery when you move like this?
Huh?
From a minus to plus. So I'm going to
Yes,
write
sir.
plus 1.5 volt. So you're on a trip inside the circuit. You are on a trip inside the circuit. Now tell me, when you move to the next part, which is a 20 ohms and has a current of I1 plus I2, what is the potential drop you will see? 20, which is a Ohm's law, right? I into R.
Hmm.
You are on a trip inside the circuit, and your current focus is this part of the circuit that carries a current I1 plus I2 and has a resistance of 20 ohms. Any doubts in your mind?
No.
Okay. Move. So you have covered this. You are on your trip. Then you have to go along. So now you're moving like this. You see another 200 ohms. There is a potential drop there also, right? So
Yes, sir.
plus 200 into I3. Again a drop. So the left hand side is your EMF. Based on the way you traveled, you saw a gain, you wrote plus, and on the right hand side, all the drops.
Hmm.
let's go to, so you have applied the Kirchhoff's voltage law to the left loop. So you have written the first equation where you see a lot of unknowns, I1, I2, and maybe, I3 is also unknown. And the question is you have to find current in each of the branches. The branch number AB, the branch number ADB, and then the branch number ACB. All these currents have to be found.
Okay.
Analysis means find something. Find current, find potential across BC. Tell me what is the potential across DC. Those things, right? But before
Hmm.
doing that, you must be able to identify in each branch what is the current.
Yes, sir.
Okay, let's go to the number 2. Let's talk about number 2. Okay, so that's your second loop, and I decide to go the way I've already drawn like this. When I'm on a journey inside the circuit, the first thing I come across is a 60 ohm resistance carrying I3, and I am also in the same direction, by the way,
Hmm.
as the current. I am going to travel the loop in the same way because I decided to make it a clockwise one. This one was anti-clockwise, this is clockwise. Second, what will I write on the right hand side? 60 into I3. It's a drop.
Hmm.
Then I move further. I see a battery. Is it a gain or a loss when I move? First, I come across a negative terminal and then a positive terminal. A
Gain.
gain or a loss?
Gain.
Pump. What is a pump on the left hand side? The electromotive force pump. Let me move further. Okay, so this is the way I'm moving. What do I see? Again, I see a 20 ohm resistance. A loss, right? A potential drop.
Hmm.
Now let us consolidate our equations. First, the Kirchhoff's current law at A or B told us that I1 plus, if this is I1 and this is I2, okay, then we already know that. So we already used at B and C the fact that the current in AB is I1 plus I2. We already knew that, right? Because this is the current we assumed because of the 1.5 volt, and then we assumed I2. So this was I1. So I1 and I2 got added at A, and when it left A, it was I1 plus I2, which is now entering B and then leaving B as I1 and I2 again. So we know there are two currents in the circuit. The third current, which is I1 plus I2, can easily be found out if we add I1 and I2.
Hmm.
Now we have two equations. Let me write the two equations. So one equation is 1.5 is equal to 20 I1 plus 20 I2 plus, I have written 200 I3 for this, right?
Hmm.
This is I1 actually, right? Because it is the same.
Yes, sir.
So 20 I1 plus 20 I2 plus 200 I1. So 1.5 is equal to 220 I1 plus 20 I2. Equation number 1, x and y variable, two unknowns, I1 and I2. Equation number 2, 4 is equal to 60. I have written this is I3. In fact, this is I2 only because it is same as this. The
Hmm.
current coming from the battery, right? So this will become 60 I2 plus 20 I1 plus 20 I2. Okay, then let's continue writing this and solving this. So 4 is equal to 20 I1 plus 80 I2. And then we have equation 1.5 is equal to 220 I1 plus 20 I2. I have two equations to solve. Multiply this by 11. So 44 is equal to 220 I1 plus 880 I2 and 1.5 is equal to 220 I1 plus 20 I2. Subtract 44 minus 1.5 is equal to 0 plus 880 minus 20 I2, and therefore this will become I2 is equal to 42.5 divided by 880 minus 20, 860 amperes.
Hmm.
Put the value of I2 in any of these equations and you will find I1 also. If you know I1, then add both of them and you will know the current in the third branch, which is the diagonal.
Hmm.
But sign convention more importantly. I hope this was clear. It
Hmm.
wasn't too difficult, right? It was just writing it carefully. Okay, let's see what happens if I do something else now. I will just use this circuit, copy it, and tell you what happens if somebody else decides to apply the same thing in a different fashion and says, no, I will not go with your direction, which is the clockwise or anti-clockwise. I will have my own choice and free will to apply that. Let's put it this way. So somebody says, I am going to use this approach. So he draws the circuit, redraws the circuit, and says, same circuit, everything same about the circuit, no change, and a battery, same junction, same point B, same diagonal resistance, same battery, nothing is changing. Not
Hmm.
an inch of this circuit changes. Okay, this is 60 ohms. This is the other battery, which is 5 volts. And the other battery is your, for example, it could be, this is 4 volts or maybe 1.5, what we took otherwise, right?
Hmm.
1.5. And the currents are 200 and, sorry, the resistors are 220 and 60 ohm respectively, right? But now somebody says, okay, I agree that the current will go like this, right? So I1, I2, and so far so good. There is an agreement between both of you. But he says, Garvit, I will not agree with you that you have to take, because you find it convenient to move like this. I don't want to move and go around the circuit like this. I want to go around the circuit in an opposite manner. It's my choice. I don't want to just blindly go with the current. So he says, I will move in the circuit like this, clockwise.
Hmm.
And then he says, you have taken clockwise on the right hand side. You moved like this. I will not move like this. I would like to move like this.
Okay.
Very different from your thinking. So each two is on. Both are free, both are right. Okay, but how will you apply the rule now? Let's see. So you are moving across the circuit, the mesh number 1, and assume you first thing you do is you are moving and you reach here. The battery. What will you write as your pump now? Positive to negative, gain or loss?
Loss.
On the left hand side, you will write minus 10.
Hmm.
Move forward. The current in the circuit is this,
Hmm.
and now you are going like this. So you see a drop here, right?
Yes, sir.
Which you're supposed to write on the right hand side. But do you see that the current is leftward and you're moving rightward?
Hmm.
So whatever drop you get, which is 200 into I1, put a negative sign there also. Because the direction in which you have decided to go through the circuit and the current direction is opposite, not like this where they were in agreement with each other, they have now become anti-parallel. the way you move and the current. So therefore the drop is a negative drop. And move forward and reach here. Do you see again something very similar happening on 200 ohms?
Hmm.
20 ohms, I'm sorry. This is 20 ohms. You are again moving in clockwise. You're again moving clockwise, but the current is in the opposite direction. So your drop again is 20 into I1 plus I2. If you remove the negative sign from all of this, you will get 1.5 is equal to 200 I1 plus 20 I1 plus I2. You're back to square one. If you compare this with your previous situation, it is identical. The only thing is because you traveled in the reverse direction, as per the sign convention, the drops became negative because your movement and the current's movement was opposite. So wherever you saw a drop, you put a minus sign. But all the minus sign got removed and you're back to square one.
Understood.
So it does not matter. The only thing that matters is if your movement is in agreement with the current movement, just write plus that drop on the right hand side, and on the left hand side just write what is the nature of EMF force. If you're moving like this and you come across battery like this, it's a loss. But if you're coming like this on the same battery, it is minus to plus, which is a gain.
Hmm.
But then on the right hand side also things will change. So no impact gets created because of choice of direction of currents or the mesh, the way you will traverse the loop. One is of course the current direction, which you decided based on the battery's caliber of sending out the current. So you decided the current here I'm going to take as anti-clockwise anyway. These two are sending here, current gets added. So you have already decided the current. Sometimes you will not be able to decide this also. You will have to assume the direction of the current because the circuit will be so complex. In this case, you could see the batteries giving out the currents at the junction, and therefore the external current was easy, the third current, the,
Hmm.
the current which is leaving the junction. Sometimes you may not be able to see this and you will have to decide. But somebody says, I don't know, I'm going to write this. The current direction here is this. Then I'm going to tell him there are three input currents, I1 plus I2, and I will call this I3. All are entering the circuit, but nothing is leaving the junction. Everything is
Hmm.
entering the junction. So the 0. Because whatever is entering should be equal to whatever is leaving. Leaving is 0. Everything is entering now. Entry number 1, entry number 2, and entry number 3. All three are entering. Then on the right hand side, I will write 0 because nothing is leaving. Automatically, I1 plus I2 will again become equal to minus I3, which is same as what we had written, I1 plus I2 leaving the circuit.
Understood.
Even that choice is yours. You can decide. But it is
Hmm.
always good to apply the Kirchhoff's junction law at the junction. It gives you a valuable insight. This is also Kirchhoff's current law. But the
Hmm.
assumption was the current is entering from all the three sides, all the three branches into this. But
Okay.
that was a very uncomfortable way to do this. The comfortable way would have been a current is entering like this from a battery, another is entering like this. Two are entering, let's assume this to be the leaving current. Makes your life easy.
Hmm.
Tell me if
ठीक है.
any doubts in your mind that come that,
No, no, sir.
okay, let's draw a circuit again and let's discuss the circuit. These are the types of questions you get in CBSE board. And moving forward, slightly tricky question. Already used something like this earlier also. Okay, so this is my, and I will help you in this question, but I will leave it to your judgment on taking decisions as to how you will solve this question. Okay, so you have to calculate the current here, the current here. So I'm calling it I1. Don't worry about the arrow. You can take a reverse arrow. I leave it to your judgment. I took a arrow upwards because I saw battery of positive. So the currents are leaving. This is I2 and this is I3. The two batteries are, for example, 20 volts and 40 volt respectively. And this is I1. R1 you can take any value of your choice, 10 ohms, and this is 20 ohms. Now I leave it to your judgment to find out the value of I1, I2, and I3. And what you have to use now is the knowledge of Ohm's law, which is obviously the potential drops is I into R. You have to use series and parallel, but I see nothing law and the Kirchhoff's voltage law. These are the three laws. You know each one of them. So select the respective meshes and loops, give directions of the current, take junctions, see what is entering the junction. So you have I1. Just give me 1 second. Just give me 1 second, please.
Yes, sir.
You continue to solve this. I'm watching you. Don't worry. I'm just going on mute. Continue to
Hmm.
solve this and give it a shot. Garvit, I don't see any drawing from your side. Yeah. Take a loop, select the mesh, mark the junctions.
Hmm.
Step number 1, yes. Don't worry about being right or wrong. Just do it.
Board does not work.
क्या हो गया?
मैं लिखने की कोशिश कर रहा हूँ, कुछ आ नहीं रहा.
Sure. Okay. Let me open the next page then. I've added one more page.
Okay.
Okay, third page. Use that. It's empty. Just copy that question on the
इधर भी
page
नहीं हो
number
रहा.
3.
इधर भी नहीं चल रहा.
Okay.
अब चल गया.
Okay. कौन सा चल रहा है? 3 or 2?
ये तो पेज 1 ही है.
Okay. So you can just draw the circuit. I will redraw the circuit.
Okay.
Okay, so this is your circuit 1. There is a battery. All right, let me just draw the circuit.
Hmm.
I think we've written too much in that. That's all. These are the only two currents I'm showing direction for. Rest is your choice. You have to find the current in each of the branches.
Okay, sir.
ठीक है. Yes, you're right. But apply the Kirchhoff's current law first on the junction. आपने सारी branches के अंदर where have you shown the currents? I1, I2 is visible. Where is the current in the middle branch? Where have you
Minus.
marked your junction? Step number 1, mark your junctions where three branches meet.
Okay.
Also keep names A, B, C, D, E, F.
Okay.
ये भी याद नहीं. So let's say this is one of the junctions. एक ब्रांच लेफ्ट से आ रही है, ब्रांच ये वाली. ये दूसरी एक सी से आ रही है, एक ई से आ रही है, एक ए से आ रही है.
ठीक है.
डी इज अ जंक्शन. सी से जो ब्रांच है उससे कितना एंटर हो रहा है डी में?
5
I1.
I1 current.
Okay. What is the current entering from the right hand side?
I2.
So if two currents are entering, for simplicity, I have taken the third current is going out. This is my choice. So what should be this current? If I know two currents are entering, one is I2.
I1 plus I2.
लिख दो. First step should have been to identify the junction and apply Kirchhoff's current law there. अगर आपने नाम ही नहीं रखे करंट के तो आप किरचॉफ्स वोल्टेज लॉ लगाओगे कैसे इस ब्रांच में जब आप मेश को चुन लोगे, जो आपने दो चुन लिए.
यस सर.
ठीक है. Let me see. So you are moving like this. So you want to move like this, right? तो आप टूर पे निकले हो, ये आपका टूर शुरू हुआ आपको. ओके. फिर आपको दिखा कि जिस डायरेक्शन में टूर है और जिस डायरेक्शन में करंट है वो सेम ही है, तो आपने इसको प्लस ही रखा, ड्रॉप. फिर आप आगे गए, कुछ नहीं मिला. फिर आप नीचे आना शुरू हुए तो आपने देखा कि जो आपकी टूर की डायरेक्शन है और करंट की डायरेक्शन है वो सेम है, तो आपने 1 इंटू सही करा. दिस इज करेक्ट. गो टू द. सो नाउ यू already applied KCL here, and now you are applying KVL. You've
Yes, sir.
applied KVL in mesh number A, so let's call it X. This is mesh number
Y.
Y. Okay, so now you're moving. Yes, you see your loss. You see your loss, and then you continue your tour. You go like this. Oh, you're against. Your tour is against the current direction.
Yes, sir.
Okay, so put a
Minus
yes, yes, correct, and continue with the tour now because you've covered this. You have covered this, and you're left with.
minus 2 I2.
Okay, let me see. Yes, because your tour is like this.
Against.
Yes, पर माइनस साइन तो चला ही जाएगा, सब में है ना.
हाँ, हट जाएगा.
Now open this first. Write the simplified form. Collect I1 together.
Okay. Got it. These are simple equations.
Yes. X and Y. Solve X and Y and find X and Y.
Okay.
अच्छा, then you want to put the value of I2 in the other one.
Substitution.
ठीक है, चलेगा, works. I2 तो आपके आ रहे हैं, माइनस हटा दो ना सब में से,
ठीक है.
प्लस ही हो गए सारे. So you have I1 plus 3 I2. I1 plus 3 I2. Correct. Open the bracket. Hmm. 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 Minus 27. Correct. Perfect. Perfect. Amperes. Find I2 now, because I will ask you. Put it here. Find I2 also.
Okay. I2 at yes. सर आपका कर्सर आ रहा है.
Gone.
Yes sir.
क्योंकि मैं आपको उससे कुछ पूछने वाला हूँ, विच इज बियॉन्ड दिस, राइट. स्टैंडर्ड तो आपने देख लिया कि निकल गया था. एक देयर इज अ फिक्स्ड मेथड टू इट. इफ यू फॉलो द मेथड यू गेट द आंसर. सिंपल. Okay, but let's see. Then I will take you to some other trip within the circuit and tell you how to find other things in the circuit. 6 sevens are 42. 4 is 162.
62.
ठीक है.
170.
8 by 17.
हाँ 8 by 17 रह गया.
All right. Amperes. Amperes, okay? All right. Let's look at the circuit now. Okay, let's go back to the circuit.
Yes sir.
Tell me the potential between VF and E.
Okay.
Which means if you move from F to E, what do you notice? Start traveling from F to E. Start going.
Positive voltage.
ठीक है. So +3.
Hmm.
You're not applying Kirchhoff's voltage law. This is a branch, remember. This is a branch. VFE is a branch, right?
Yes sir.
It's not a mesh. So you move through the branch. अब branch के ऊपर चलना शुरू कर दो आप. सबसे पहले आप F से जब ऊपर जाओगे तो सबसे पहले क्या मिलेगा आपको?
3 voltage.
ठीक है, लिख दो. गेन है, लॉस है, वो तो पता ही है.
Gain.
ठीक है, गेन लिख दो. कहीं भी लिख दो. You can write it here.
Okay.
3 +3. No, you're not applying mesh law.
Okay. Okay.
There is no equal to here. Okay. Now go up. उससे भी ऊपर जाओ. क्या दिख रहा है आपको? एक और रेजिस्टिव एलिमेंट आ रहा है. उसमें कितना ड्रॉप हो रहा है?
-2.
नो, -2 कैसे आ रहा है? ये तो सिर्फ ओम्स है. ड्रॉप, पोटेंशियल ड्रॉप क्या होता है? I into R. Right? Potential in a resistor in this direction. So there will be a loss, right? ये higher to lower है. So I2 तो मालूम है.
Yes sir.
तो यहाँ पे I2 डाल दो. मल्टीप्लाई बाय R कर लो.
Hmm.
And it's a loss, right?
Yes, sir.
Answer.
Okay.
Which means if you have a branch, and I tell you the potential difference from here, this is 3 volt and this is some current 1 ampere and this is 1 ohm. Start from A to B.
Hmm.
प्लस 3 माइनस 1 into 1. यहां तो ओम्स लॉ लगाऊंगा ना मैं.
Yes, sir.
So my VAB is equal to 2 volt.
Okay, understood.
Now let me ask you. This is a branch. VAB. VAB is given to be 6 volts. This is 2 volts. And this is 1 ohm. What is the current flowing here? So you know 6 volt is getting consumed from A to B. A is at higher potential.
Hmm.
Okay. What is now the current in this branch? Use the same logic. Start moving. VA to B is actually VA minus VB. One and the same thing.
Hmm.
Potential difference between, right? So VA minus VB is equal to 6 volts. Now start moving from A to B. What is the first thing you notice? Gain.
Voltage. Yes, sir.
Gain, right?
Hmm.
Now you are also, when you move from, you will lose some potential here, right? So this will be, there will be a drop here.
Hmm.
So VA minus VB as you're traveling should come out to be the potential difference between A to B. You're moving from A to B. In the middle, you get, when you travel, when I say VA, VA is at higher potential, right? So this is at 6 volt and this is at 0 volt.
Hmm.
So VA minus VB, let me just move. So first thing I come across is 2. The second thing I come across is a drop, a loss. And I know how much is this? 1.
Hmm.
So I write X is equal to 2 minus X is equal to minus 4 volt. Which means the drop here is minus 4 volt. What does it mean? What does it tell you? That the drop is minus 4 volt from here to here. So which means the drop from here to here will be positive, right?
Hmm.
So the current in fact is traveling like this.
Yes, sir.
Got it?
Hmm.
See again. VA minus VB is equal to 6 volt. Move from VA to VB. How will you move if you have to move through this? First a gain, then a drop. So you're getting minus 4 ampere flow, which means whatever current you assume, the current actually is in the opposite direction.
Okay, sir.
ठीक है?
Hmm.
तो कई बार वो क्वेश्चन के अंदर सिर्फ इतना ही नहीं पूछते हैं कि यू हैव टू जस्ट फाइंड they will go to an individual branch in the circuit, and then they will ask you, okay, my question to you is, what is the potential drop across 5 ohm? You have calculated I, multiply answer, I into 5, potential drop,
Yes, sir.
right? Let's try one more question here, okay? All right. Let's draw one circuit and see. So this is your circuit, and this is your battery, and this is your circuit. This is again your battery, and this is your battery. Okay. And this is, for example, 2 volts. This is R. This is D. This is 2 ohms. This is 3 ampere. This is 4 volt. This is 3 ampere. So good information on current is available to you. Okay, and this is also 1 ampere. ठीक है? Question is, and this is also 3 amperes, and this is R1. It is given that the potential of the point A in this circuit is 0. So this potential is 0. Actually, there is a grounding here, right? So maybe ground से connect कर दिया. VA, A point पे potential is, so this is A. Let me just rub this off, okay? VA is equal to 0.
Yes, sir.
You have to find the potential at the point B. This is 1 ampere. Okay, let me just write it cleanly so that you understand. Let me just redraw this. Okay, let me just show you a, there's a resistance here which is given to be R, and the current through it is given V is equal to 0, and you have knowledge of so many currents also. You have to, this is given to be at 0 potential. Find the potential of B. Your question is, what is the potential of B? Now the currents are given, he is asking you specific potential there. जैसे हमने ऊपर वाले केस के अंदर हमने बोला था इस ब्रांच में पोटेंशियल ड्रॉप कितना है पूरा, तो आपने बैटरी और ओम्स लॉ लगा के निकाल लिया था, बट अब क्वेश्चन चेंज हो गया थोड़ा सा. डू द सेम थिंग, नो चेंज, अप्लाई द सेम ट्रिक, कुछ मत करो. VA इज इक्वल टू 0 का फायदा उठाओ, दोबारा से वही लो. 2 मेश नजर आ रहे हैं, 2 लूप नजर आ रहे हैं. ये 1 एम्पियर है. आउटवर्ड पहले क्या करना होता है, जंक्शन ढूंढना होता है. आपके हिसाब से इसमें जंक्शन कौन सा है?
D.
इसमें आउटवर्ड करंट कितना है? 1. इनवर्ड करंट कितना है टोटल? 3. तो ये कितना हो जाएगा? 3 घुस रहा है, 1 जा रहा था, और ये कितना होना चाहिए?
2.
ठीक है. सो करंट तो सब जगह ही पता चल गया. 2 मेश ले लो, पूरा सॉल्व नहीं करूंगा, ये ले लेते हैं, कन्वीनियंट रहेगा, करंट के साथ दौड़ चलना. इधर भी यही ले लेते हैं, करंट के साथ ही चलते हैं. अप्लाई द किरशॉफ्स वोल्टेज लॉ, और कुछ यू कांट अप्लाई एनीथिंग एल्स, राइट? और पता भी कुछ नहीं है,
हम्म
यही दो लॉ होते हैं। लगाना शुरू करो। पहले लगाओ डी, इसका नाम रख लो, कुछ भी रख लो, के, डी के ए सी में लगाओ, जैसे नॉर्मल लगाते हैं लगाते जाओ। आर की वैल्यू भी नहीं पता बाय द वे, ओके? नहीं मालूम है, नहीं दी। लगाओ डी के ए सी में लगाओ। नॉर्मल जैसे लगाते हैं बिल्कुल, बट ट्रैवल
हम्म
करो, लिखते जाओ आंसर। एक चीज पता है लेकिन आपको अंदर से कि ये जीरो डालना है मुझे, तो देखते हैं कैसे वो जीरो डलेगा। ठीक है, लिखते जाओ। ठीक है, सो व्हेन यू वर गोइंग थ्रू दिस इट वाज पॉजिटिव टू नेगेटिव, ठीक है, इज इक्वल टू, हाँ ठीक है, लिखते जाओ। बढ़िया जा रहे हो। एंड यू गो, हाँ वो दोनों एक दूसरे के अगेंस्ट है, तो ड्रॉप इज नेगेटिव, राइट? एक ऊपर आर भी है,
यस
उसमें भी करंट मालूम ही है, तो जो भी है वो तो सेम डायरेक्शन है मेरे, नहीं वो भी उल्टा है, नहीं वो सेम है, आई थिंक वो सेम ही है, राइट? ये तो सेम ही
सेम
लग रहे हैं।
डायरेक्शन हाँ
हाँ, तो ये तो नॉर्मल प्लस ही लिखना है आपको, बट इसमें करंट आपका दे रखा था कितना, इट वाज 1 एम्पियर, राइट? दिस इज 1 एम्पियर, राइट? 1 एम्पियर, करेक्ट। आर, यस,
तो आर की वैल्यू आ जाएगी
करेक्ट।
2 हो गया आर
तो एक लेफ्ट हैंड साइड से कुछ ढूंढ लिया,
हम्म
लेकिन अभी भी इसका कुछ खास यूज हुआ नहीं। लेकिन जब मैं
यस
बोलता हूं फाइंड द पोटेंशियल ऑफ बी, रिमेंबर किसी भी पॉइंट का पोटेंशियल विद रिस्पेक्ट टू जीरो ही होता है।
हम्म
तो आपको वी बी जो निकालना है, बेसिकली आपको अंदर से निकालना है वी बी ए, मने वी बी माइनस वी ए। भाई आप जब बोलोगे व्हाट इज योर पोटेंशियल अबव द सरफेस ऑफ द अर्थ, तो विद जीरो पोटेंशियल पे तो अर्थ ही है ना,
हम्म
तो जो भी पोटेंशियल होगा ऊपर इस डायरेक्शन में होगा, एम जी एच या जो भी निकालोगे। बट
यस सर
कोई पॉइंट तो लोगे ना, वे कहां से नाप रहे हो, नापने का पॉइंट ही है, तो वी बी ए निकालना एक्चुअली आपको। अब सेकंड में चले जाओ, सेकंड मैश के अंदर जाओ, सही जा रहे हो, बिल्कुल करेक्ट है। यू मूव अलोंग द, यू मूविंग लाइक दिस, राइट? सो इट्स अ गेन, यू आर मूविंग इन द सेकेंड वन, राइट? तो आप सबसे पहले किस में जा रहे हो, 2 ohms। अच्छा, यू ऑलरेडी रिटर्न दिस, ओके। सो -2, व्हाट इज -2?
ये
अच्छा नहीं
फर्क
लिखा, अभी लिखा नहीं आपने कुछ भी, ठीक है, यू हैव नॉट रिटर्न एनीथिंग, ओके। ऑल राइट, सो +4, yes, it's a gain, and then you're moving like this is equal to 4, 2 into 2,
ये तो 4 ही हो जाएगा
आगे बढ़ना शुरू करो और इसमें जाओ।
प्लस 3R1।
हाँ, क्या हुआ, ये भी कट गया।
0 हो गया R1।
ठीक है, देयर इज नो रेजिस्टेंस देयर। ठीक है, रीड्रॉ द सर्किट एंड रिमूव R1 फ्रॉम देयर, राइट, हटाइए दो उसको। दो अननोन भी पता चल गए मैश में, राइट,
यस सर।
दोनों मैश में। तो रीड्रॉ दिस सर्किट, देखते जाओ सर्किट ड्रॉ करके, रीड्रॉ कर दो, R1 हटा देना वहां पे, देयर इज नो R1 लेफ्ट नाउ। वेयर आर यू रीड्रॉइंग?
डाउन।
ओके, बहुत मुश्किल नहीं है करना,
हम्म।
थोड़ा सा मतलब। ओके, होल्ड ऑन होल्ड ऑन होल्ड ऑन। तो आपका वो राइट साइड पे सर्किट कहाँ गया? बैटरी, 4 वोल्ट की बैटरी तो रहेगी ना, सिर्फ रेजिस्टेंस हटाना था आपको। बट दूसरा
अभी बनाया नहीं है
अच्छा,
मैंने।
बनाया नहीं है। ओके, गॉट इट, वही आई वाज थिंकिंग है, दूसरा सर्किट थोड़ा गुम हो गया।
हम्म।
गॉट इट, ठीक है, सही है। अब सिर्फ बैटरी बैटरी रह गई। बी वेरी केयरफुल इन लेबलिंग, क्योंकि पॉइंट भी हमारा कहीं और है दोस्त। पॉइंट भी ये है, आपने इसका नाम बी रख लिया ना, कीप इट सी। सही जा रहे हो। ऑलराइट, अब उस पे बी लिख दो जाके, यहाँ पे कहीं भी लिख दो। ये तार है बेसिकली, तार पे तो कुछ भी हो सकता है,
हम्म।
आप कहीं भी लिख लो बी। सो बेसिकली इफ यू सी नाउ, नाउ टेल मी व्हाट इज योर थिंकिंग अबाउट वी बी ए। तो आपको यहाँ से चलना है, यहाँ पे टूर यहाँ से शुरू करना है आपको,
हाँ।
और यहाँ तक जाना है। देखो क्या आपको लगता है टूर के हिसाब से क्या आएगा आंसर? ऊपर से भी जा सकते हो, यू कैन गो लाइक दिस ऑल्सो इफ यू वॉन्ट, यू कैन ऑल्सो गो लाइक दिस इफ यू वॉन्ट, कोई फर्क नहीं पड़ने वाला, आंसर इज गोइंग टू बी द सेम। बट आई थिंक द इजिएस्ट होगा कि यहीं से चलो,
हम्म।
क्योंकि इतने सारे वो करने नहीं पड़ेंगे ना, आई आर
यस
ड्रॉप्स।
सर।
ठीक है,
VB is equal.
So let's say the potential is VB is VB, right? ये VB पे है और आपको निकालना है VBA, right? Which is equal to VB minus VA. मेरे को ये बताओ, ये जो पॉइंट B है, if this is at potential B, can we say it is connected to this point?
Yes, sir.
कुछ है ही नहीं ना बीच में ड्रॉप का सीन, और ये नेगेटिव साइड पे जुड़ा हुआ है बैटरी की,
Yes, sir.
तो ये नेगेटिव साइड ऑफ द बैटरी है, राइट? एक तरह से। और ये वाली जो साइड है ए वाली, तो ये वाला जो पोटेंशियल है, ये अगर मैं इसकी बात करूं, हाउ कैन आई लेबल इट? कैन आई से दैट दिस इज ऑन द नेगेटिव साइड, सो दिस इज एक्चुअली यू नो लेट्स से this the potential here and the potential here, B and C are identical because कोई बीच में ड्रॉप नहीं हो रहा। यहां से चलता हूं, कोई ड्रॉप नहीं आता, कोई ड्रॉप नहीं आता, कोई ड्रॉप नहीं आता, वहीं पे पहुंच गया मैं। सो जो पोटेंशियल B का है वही पोटेंशियल C का है फिर,
Yes,
because
sir.
B and C are connected to the same and without any drop। अच्छा, अगर मान लो ये मेरा पॉजिटिव साइड तो जोड़ नहीं रखा, तो मैं इसको -4 लिख लेता हूं, ठीक है? अब आगे बढ़ता हूं मैं। अब देखो ये जो है -4 पे है, और जब मैं आगे बढ़ूंगा, व्हाट विल आई गेन समथिंग?
Yes, sir.
सो आई वाज एट -4 एंड आई मूव्ड फॉरवर्ड, व्हाट डिड आई गेट? +2।
हाँ.
क्या आंसर आ गया देखो?
ठीक है.
समझ आया क्या हुआ है?
हाँ.
सो समटाइम्स द क्वेश्चंस आर बिट ट्रिकी। VA इज इक्वल टू 0 लगा लिया, तो भैया A का जो नेगेटिव साइड, मतलब मैं अगर यहां से चलना शुरू करता हूं, अभी ये 4 वोल्ट है, राइट? ये अगर मैं इस तरफ से जोड़ के रखा होता, अगर बैटरी उल्टी होती, तो B का पोटेंशियल इस साइड क्या होता? 4। और फिर मैं अगर जाता नीचे की तरफ ऐसे, तो पहले तो मैं 4 पे यहां 4 वोल्ट लिख लेता, और एक बैटरी उसमें ऐड हो जाती 2 वोल्ट की, तो मेरा 6 वोल्ट आ जाता आंसर। मेक सेंस टू यू?
Yes, sir.
So this is a way you need to solve it. We will do more practice, but my suggestion is go to SL Aroda or whatever book you use, NCERT exemplar. Do 3-4 tricky questions like these.
Okay, sir.
ठीक है? It'll give you a very good hand practice and confidence level will go up because of that. You can also go to NCERT, see some solved questions of NCERT. They're also very nicely written.
Okay, sir.
ठीक है? See
Yes,
you
sir.
in the evening then. Bye.